Good morning, children. Welcome to today's class. Today we will revise the second part of the first chapter, matter. So let's start. So change of state of matter. So in two manner we can do this. One is by change in temperature and another change in pressure. Uh, the first one, change in temperature. If we heat a solid, when we will be heating the solid, we will get the liquid. It's uh, the particles of solid on the or the molecules of solid, they will absorb energy. Their kinetic energy will increase, and the particles, they will their intermolecular gap will increase, and they will come to the state of liquid. In the same manner, if we heat the liquid again, the same manner we will be getting the gaseous state of it, as the uh, intermolecular space between the liquids will increase and they will convert to the gaseous state. Their their kinetic energy will increase again, and the force of attraction between them will decrease. And if we go the reverse process, that means the gaseous state, or the gaseous form, if we cool it down, if we take out the heat, the liquid, it will convert to the liquid, as the gaseous substances or the gaseous form of that matter, the particles of the gases, their when we will cool down, their kinetic energy will decrease, their intermolecular force of attraction will increase, and they will come closer. Okay, so we will be getting the liquid form of it. Again, from liquid we will be getting the solid form by cooling it down. So this we can get for the state of water also. So solid state, that is ice will convert to liquid water by heating. So the particles of or the molecules of ice, their intermolecular force of attraction will decrease on heating, their kinetic energy will increase, and their intermolecular gaps will increase. So we will be getting the water, liquid form of it. Again, from water we will be getting the steam or gas, which is the gaseous form of water, by the same heating process. Okay, so again, if we go the reverse process, that means from steam, if we cool down the steam, we will be getting the liquid form of it, that is water, and from water we will be getting the ice form of it. Okay, the same thing we will be getting for rocks also. Solid rocks, when we will heat that, it will convert to the liquid rocks, and from liquid rocks, when we will be cooling it down, we will be getting the solid rocks. So the reason behind it is, and the kinetic energy will increase when we will be the substance or the state of the matter will absorb heat, and their kinetic energy will increase, they will vibrate more vigorously, and they will be their gaps between the particles will increase, their intermolecular force of attraction between them will increase, and force of attraction will decrease, and they will be forming the solid form will convert to the liquid form, liquid state. And again, if we repeat the process, the liquid state will convert to the gaseous state. Okay, and if we go the reverse process, that means if we cool it down, just the reverse thing will happen, kinetic energy will decrease, and the space between them will decrease, and force of attraction will increase. Okay, and this will affect the movement of the particles, the random movement of the particles, that will decrease, and the gaseous state changes into a liquid state, and which on further cooling changes into a solid state. Now for sublimation, directly from solid state we will be getting the gaseous state, and from gaseous state, if we go reverse, that means if we cool it down, we will be getting the solid state. Camphor, iodine, naphthalene, dry ice, ammonium chloride, they will show the sublimation process. Okay, another process is there by which we can change the state of matter, by changing the pressure. If we apply pressure and if we decrease the temperature, then the substance can be converted into from solid state, it can convert to the liquid state, or the liquid state can be converted into a solid state. So from gases, generally if we apply pressure on the gases, it will convert to the liquid form of it. Okay, so during the applying of pressure, if we apply pressure, then the particles can come closer, the particles will come closer, so their movement will decrease, their kinetic energy will decrease, and they will come closer, and their force of attraction will increase. So from gaseous state we will be getting the liquid state, and from liquid state we can get the solid state. Okay, the LPG, and in this process we can obtain liquid oxygen, liquid hydrogen, etc. The gases we can convert to the liquid form by applying pressure and lowering the temperature. So LPG cylinders of cooking gas, they are having liquid state of the gases at high pressure. Okay, we are converting the gas into liquid at high pressure. Okay, now there are few terms related to this interconversion of state of matter. This we know already, that is fusion, or melting, or fusion, evaporation, freezing, and all. Here we will be discussing the melting point and freezing point and all. Okay, so what is melting point? There is a fixed temperature at which a solid changes into a liquid at atmospheric pressure. The temperature is called its melting point. This melting point is fixed for a particular substance at a particular, and is when atmospheric pressure will be fixed. Okay, at atmospheric pressure only we will be measuring the melting point or boiling point and all. Okay, so this temperature is fixed for a fixed substance, we will be saying. That is, for ice it is 0 degree centigrade. Melting point of ice is 0 degree centigrade. The same manner we will be getting the boiling point. So the fixed temperature at which a liquid starts changing into gaseous state, that is called its boiling point. Hope you can see this. At this temperature, the pressure of the liquid becomes equal to the atmospheric pressure. At boiling point, the pressure of the liquid becomes equal to the atmospheric pressure. Okay, for condensation we are having condensation point. So it is the temperature at which a gas starts changing into its liquid state, that is called condensation point. Liquefaction, what is this? This process is by which a gas is changed into its liquid state by applying pressure and lowering the temperature, that is called liquefaction. The process by which a gas is changed into its liquid state by applying pressure and lowering temperature. And by liquefaction process we are getting the liquid oxygen, or liquid nitrogen, or liquid hydrogen, etc. Freezing point, the temperature at which a liquid starts changing into its solid state is called its freezing point. For pure water, this is 0 degree centigrade under normal conditions. Okay, next sublimation, this you know, not repeating this again. Law of conservation of mass, what is this? The matter can neither be created nor be destroyed in a chemical reaction. This is the law, law of conservation of mass, which states that matter can neither be created nor be destroyed in a chemical reaction. That means during a chemical reaction, the total mass of the reactant is equal to the total mass of the product. In a chemical reaction, the total mass of the reactant is equal to the total mass of the product. Means there is no change in the mass during a chemical reaction. So this can be verified, this law can be verified using certain reactions or experiments, we can say. Okay, for this, the first experiment, we will be taking some barium chloride solution, aqueous barium chloride solution in this small test tube. Here you can see this where I am indicating. In this small test tube, we will be taking barium chloride solution, and in this conical flask, we will be taking this sodium sulfate solution. It's leveled also, see, sodium sulfate solution, this one. And we will be using cork, thread and all, so that this too will remain in a closed manner, in a closed system. Now we will be shaking this conical so that this barium chloride will get mixed with sodium sulfate, and these two will react together. These two will start the reaction, and in this reaction we will be getting barium sulfate as precipitation, white precipitation. Along with, in solution, we will be getting sodium chloride. This. Now, in this reaction, in this experiment, before mixing this two solution, if we take the weight of this whole system, and after the reaction again, if we take the weight of this whole system, we will find that the mass of this system before reaction and the mass of the system after reaction will be equal. That means the total mass of the apparatus plus the reactant is equal to total mass of the apparatus and plus product. That means the law of conservation of mass is verified. This verification we can do with another experiment. For that, we have to take a plastic bag with Ziploc, vinegar and baking soda. So in this experiment, in this plastic bag, we will be taking the vinegar. You can see it's indicated also, and in a small in a piece of paper, we will be taking some baking soda. Now, before doing the reaction, we will take the weight of this whole system, means the plastic bag along with the content, and we will be noting down the mass. And after this, we will be mixing this two. We will just shake the plastic bag so that the baking soda come in contact with the vinegar, and the reaction will start, as soon as we will be getting the effervescence due to the gaseous carbon dioxide. So here the reaction which is taking place, that is sodium bicarbonate, that is baking soda, okay, baking soda along with acetic acid, that is vinegar. So these two will react together to form carbon dioxide, sodium acetate and water. The effervescence which we will be observed, that is because of this carbon dioxide gas. Now after this reaction, again we will be taking the weight of the plastic bag, and we will find that the mass before the reaction, the mass of the plastic bag before the reaction and the mass of the plastic bag after the reaction, both are equal. So here also law of conservation of mass is verified. Now in few cases apparently it can be seen that the law of conservation of mass is not uh, it's not true, it's not matching. Okay, or we are not getting the desired result. So what are those cases? Suppose when wood is burnt in air, we are getting the ash, but the ash which is formed, that the mass of the ash which is formed, that is less than the mass of the wood. Why this? Because during this reaction, along with the ash, this product which is which are carbon dioxide and water vapor, both are gaseous. So those products will escape from the reaction medium and they are getting mixed into the air and all. So we are not taking the mass of this product into account. So if we consider the mass of this two also, the law of conservation of mass will be uh, here also that will be true. So as we are not taking the mass of the uh, carbon dioxide form and the water vapor formed, so the mass before the reaction and the mass after the reaction will not match. Similarly, if we uh, burn a magnesium ribbon in air, we will be getting a white solid, that is magnesium oxide, MgO, in this reaction. So here also, here we will see that before the reaction, the mass of the magnesium ribbon, uh, whatever we are getting, that will be less than the mass of the magnesium oxide which is formed after the reaction. Why this? Because the oxygen uh, which is getting mixed with the magnesium, that we are not considering. It is not considered. So if it is considered, then here also we will be getting the desired result. That means the mass after the reaction and the mass before the reaction will be equal. Okay, so this is all. This is all for today. Just as you are doing regularly, you go through the study material, do the worksheet, solve the worksheet, and keep on studying. Take care, stay safe. Have a good day. Thank you.